Hello, I'm going to call this lesson More Rates and Unit Rates. This continues our work in section 5.3b in the Big Ideas Math textbook, and we're looking at unit rates. So when you see the red star, you're writing this down in your graphing notebook. Also, this is lesson 45. So you're going to start a brand new page of your graphing notebook. And I want you to write down when using the word per for unit rate, you leave off the 1. An example is $2.99 per apple means $2.99 per one apple. And normally you're not going to be writing a full sentence, right? You would do this. And I want you to know that the slash is the per. So when you see a slash, you say per when you're talking about rates and unit rates. And then when deciding if two rates are equivalent, you can find a common quantity with the same number and units and then compare the price or compare the value. You can also use your unit rate, but you don't have to. I am going to show you some examples that use unit rate and some examples that use a common quantity. Okay, so we're going to start off on the example. This is in your textbook, and it talks about a piece of space junk that travels 5 miles in 8 seconds. How far does it travel per second? So here's a table, right? You know how to use a table. If I am looking for how far it travels per second, that means per 1 second. So I put the 1 here, I divide by 8, because 8 divided by 8 is 1, which means I also divide this number by 8. Okay, so now it's obviously going to be a decimal number, right? So I just get on my calculator and I do 5 divided by 8 and I get 0.625, 0.625. So the answer, if I want to do it as a decimal, this it's basically the distance that something travels over time is its speed. So the speed is 0.625 miles per second. That's how I would write that. Okay, but I want to show you what the book does. So the book with a table decides, instead of doing 5 divided by 8 as a decimal, it literally just takes the 5 divided by 8 and writes it as a fraction, right? So there it is as a fraction. I could have put 5/8 in my box, in the table. And so this is a full sentence, right? So the space junk travels 5/8 of a mile per second. You're not always going to be writing out full sentences. I probably will usually ask you to write rates like this and unit rates. Okay. So now let's look at some examples. Write a unit rate for the situation. If you, let's say you spend $44 in 4 days, how much do you spend in 1 day? That's what a unit rate would be. So I put the 44, I put the 4, and what I'm looking in is to figure out how much I spend in 1 day. So 1 is there, right? So 1 would be in every single box. You're looking for the unit rate. So when I go from 4 to 1, I am dividing by 4, and now we're just using a ratio table. We're just creating an equivalent fraction of 11. So basically, I spend $11 per day. Now I want you to know that a unit rate is also dividing, right? So I could have set it up like this and not used a table at all. I spent $44 in 4 days. And so you can see right now that you're dividing 44 by 4. You can't really divide money by days, but you can represent those quantities as a fraction. So that's why money is in the top and day is in the bottom. So you can look at all of these problems as plain and straight up division, or you can look at it as a ratio table and you're creating an equivalent ratio that has 1 on the bottom. Okay, 265 heartbeats every 4 minutes. That works out to a pretty good resting heart rate of 64. So again, I could do 265 divided by 4. That equals 64, but I also don't want to forget my units. So I could say 64 heartbeats per minute. That is my ratio, or sorry, my unit rate. Okay, 12 haircuts in 4 hours, right? 12 haircuts in 4 hours is 12 divided by 4 is 3. So that means I can do 3 haircuts per hour. And the last one is 15 liters in 3 minutes. I'm dividing by 3. This one I'll just show you, right? I keep up the ratio pattern. I'm creating an equivalent fraction. 3 divided by 3 is 1, and 15 divided by 3 is 5. So 5 liters per minute. That is my unit rate. That is probably a leak instead of how much water you could actually drink. That would be way too much water. Okay, let's look at some more problems. So how about this? Which is a better deal on cuties? There is one store that has 2 bags for $1.98, and another store has a 2-pound bag for $1.98, and the other store has a 5-pound bag for $5.99. So I'm going to show you the tables. Hey, maybe you don't have tables when you're at the store, right? Maybe what you're going to do is you're going to just get out your calculator and you're going to remember, ooh, money on top. I want to think about money per pound, right? So I could do this, $1.98 divided by 2. Over here, I would do $5.99 divided by 5. That's finding the unit rate. But I just want you to know that the other option is to think about, well, I wonder what a common quantity could be, because one of the bags is a 2-pound bag and the other one is a 5-pound bag. First of all, I'm just going to finish this division just to show you what I would come up with. This would be 99 cents, which is $0.99 per pound. And then over here, $5.99 divided by 5 equals, I have to round this using my calculator. Okay, so it's 1.198, right? The 8 tells me to bump up the 9, which bumps up the 1, so it's really $1.20 per pound. Okay, so now I can already see that the 2-pound bag is the best deal, but I wanted to show you making a common quantity. So if I put the $1.98 for 2 pounds here, and I put the $5.99 for 5 pounds here, and then what I'm thinking is, hey, 2 and 5 have a common multiple of 10. So what if I change this to 10 and this to 10 so that I can compare, right? So now I'm looking at this number. All I need to do now is do a little extra math. 2, this would be a times 5 pattern, which means I need to multiply the $1.98 times 5. When I do that, I get $9.90. And then for this one, I want to buy 10 pounds, so I'm buying 2 of the 5-pound bags. So I multiply by 2, which means I multiply the cost by 2, and I get $11.98. Well, we already knew from the unit rate, right down below, I calculated a unit rate just so you can see what it looks like. And then up here, I made a common quantity, right? Those are my 2 big strategies for comparing prices. So the common quantity was 10 pounds, and then all I had to do was compare the $9.90 and $11.98. Now, it doesn't mean I want to buy 10 pounds. It just means if I was buying 10 pounds, what's cheaper? Well, the one on the left. So I'm going to go and I'm going to buy my 2-pound bag. This is the better deal because it costs less. And I'm just going to add, it costs less per pound. All right, let's keep going. So here is an OYO. You're going to pause the video and I want you to think about, yes, there's ratio tables. Okay, if you want to go the unit rate route, you would take your $4.95 and divide it by 3 sandwiches. And for this one, you would take your $6.72 and divide it by 4 sandwiches and see which one is cheaper. I'm going to do the common quantity because I think that's easy for me and that's just what I want to do. So when I look at the sandwiches of 3 and 4, I realize that 3 times 4 is 12 and that is a common multiple. So I'm going to multiply these numbers by 4 to get my 12 sandwiches, and $4.95 times 4 is $19.80. And then for the 4 sandwiches, I'm going to have to multiply this by 3. So I multiply the $6.72 by 3, right? So now I'm comparing how much it costs for 12 sandwiches. And when I multiply $6.72 times 3, I get $20.16. Now again, it's not that I want to buy 12 sandwiches. I'm trying to find out which one is cheaper. So if I'm going to buy sandwiches, I'm not buying 12, but if I did, it costs $19.80 and the other one costs $20.16. Okay, it's not much, it's 36 cents, but it's still the better buy. So 3 sandwiches for $4.95 is a better buy, right? So that's what I'm going to do. Okay, now there are some examples that I'm going to show you because sometimes we just want to know, are the rates equivalent, right? Like if you're looking at somebody, like how you're picking a player, right? You want a player on your basketball team, and this player, one player gets 126 points every 3 games, and another player gets 210 points every 5 games. I wonder who's the better player, right? I want the one that's going to get more points per game. So I need to find out if the rates are equivalent. And I've got some options, right? I could just go the straight unit rate route. I could do this, 126 points per 3 games. So I'm abbreviating. There's my fraction. And that equals 42 points per game. And then I take the other ratio, the other rate of 210 points every 5 games. And I do the division and I get 42 points per game. Okay, so the unit rates are equal, so I know the rates are equivalent. So I don't know which basketball player I would want to choose because they both seem to score the same amount. So I would write the rates are equivalent. Oops, EQUIVA equivalent because the unit rates are the same, right? So if you do the math and you just divide, if the unit rates are the same, then the ratios are equivalent, right? Because equivalent means that they are equal. They're not identical, but they're an equal ratio. Okay, let's do another example. Oops, sorry, I mean Oyo, this is for you. This is the last 2 Oyos, and then that's it. So notice I've got tables. Maybe you want to use tables, maybe you don't, but I want to show you tables in a different way. Well, pause the video, and then when you come back, you can look at the answers. But what I'm going to challenge you to do is I'm going to challenge you to make find a common quantity to compare, because anybody can get a calculator and divide 17 by 15 and 68 by 60. But I think it's a little more interesting if you turn it into a common quantity problem like this. So what I might want to do is I'm comparing the 15 and the 60, right? Because it's per second. So I'm thinking, what if I do this and I do this one times 2 to get 30? And in this table, right, because the tables aren't the same, they don't have to be divided the same, I'm going to divide by 2 to get 30. So I'm making 30 be my common quantity. And now, right, now I've got to fill in this and see if they are equivalent. So that'll be my, right, so then there's my question mark, right, equal, question mark. Okay, when I go 15 times 2, I get 30. That means I also have to multiply 17 times 2, and I get 34. And 60 divided by 2 is 30, so that means I need to divide 68 by 2, and I get 34. Oh my gosh, that is a yes. Yes, they are equal. I've compared common quantities, and the heartbeat is 34 beats for every 30 seconds. All right. The second one, I'm going to challenge you to just find a unit rate. Maybe you can do this one with a unit rate. Okay, so when I use a unit rate, I'm literally thinking of 96 divided by 4. I get 24 per 1. And then 380 divided by 15 is 25.3, and it repeats per 1. And so the common quantities are the 1, so these are the miles that I'm looking for. They're both per gallon, but these are not equivalent. Right, so here's a car that gets 24 miles per gallon, and the other car gets 25.3. So this one is a little bit better gas mileage. So if you're trying to decide between which car to get, of course you want the one that goes further on 1 gallon of gas. Okay, oops, I need to show you, oops, I need to take my little bar. Okay, I moved the screen over. I realized that you couldn't see that I was writing unit rate, and these are not equivalent. Just wanted you to see the writing there, and that's it for today's lesson.